folks, in this video I'm going to show you how to use a solar charge controller to charge lithium ion battery. And this is not an ordinary charge controller. It's designed to charge lithium ion battery, unlike the older charge controller where you can only charge these kind of battery. Lead acid battery is heavy and you can only use it down to 50%. If you go more than 50% on these, it's gonna die on you really fast. But the newer lithium ion technology is a lot better. It's lighter, it's smaller, and it can last longer, and you can deplete down to almost zero and charge it up again, and its lifespan is a lot longer than the lead acid battery. But anyway, so this controller has got connection for your solar panel, for your battery, and for your lights. And this is a 12 volt output, so your light's got to be 12 volts. And you can also control the timing of the lights, so you can control when to turn it on, when to turn it off, how long it can run. And I will show you the inside of this controller. There's no screw on the back here, so you just pry it out like so. As you can see, it is 11.1 volts, 3 amp. So the reason why it's 11.1 is because it's 3 of these 18650. So each of these is 3.7 volts. When it's empty, 3.7 volt. When it's full, it's 4.2. But they usually you count it as 3.7. So 3 of these will make 11.1. So that's why the 11.1 volt. So this is what it looks like inside the controller. And there's no screw or anything that's holding this thing. Just pull it out like so. Let's see. Oh, my wire is sticking out. Let me remove my wire first. So I had to remove my wire. Basically here just got connection when you put in your wire to install your battery and your solar panel. And inside here there are 2 LED. This is the LED for the battery. So when you hook up to the battery, it will light up green. And when you hook up to your solar panel, this light will light up to tell you that it's charging the battery. So you hook it up. You hook up the battery first, and then you hook up your solar panel. And there are switches, right? There are dip switches. It's called dip switch, DIP. And see, there are 4 positions, and you can turn the switches on or off, right? And this is just for the lights over here. This is just for the light control. So this is just to program the light, when to turn it on, when to turn it off, and how long you want to run it. That's pretty much it. Other than that, it's all automatic. So the charging process is all automatic. It charges the battery, and when it's full, it will stop charging. It will turn on and off very quickly. Hence the name Pull Switch Modulation, PWM. In other words, it will slow charge the battery. to prevent it from overcharging. Right, so that's what it looks inside. The controller, pretty small and pretty simple. Even smaller than my battery. Smaller than the 18650. Yeah, shorter, I mean. Alright, so next I'm gonna put together and I'm gonna try to charge these battery pack, right? Pack in 3 in series to make it 12 volts. So one of these is 4.2 volt at full charge, so 3 of these is gonna be 12.6 volts, or what they call it 11.1 volt when it's empty. I'm ready to connect my battery in. As you can see, the green light is on, so it's connected. And what I have here is a pack of 3 18650 batteries. You can see it, the cell is in here. Anyway, they are in series. And you can see the cell here, 18650 cell. I can't remove it right now, but these are right now connected to the controller. And next I'm going to connect to the solar panel and see how it's going to charge the battery. I'll show you the voltage of the battery. See if we can do it with one hand right here. It's 12.4, about 12.4 volts. So it's I would say it's about 90% full. Alright, so just connected my solar panel to the charge controller, and the red light is on. Red light is on, so both lights are on. The green light is a bit dim because I'm in the sun right now, so it's hard to see the green light, but both lights are on. Okay, and it seems to be charging the battery. Let me get the meter, show you the voltage. Alright, so this is the voltage of the solar panel, which is around 12.73 volts. Let's see what's the voltage of the battery. 12.45, 46. It's going up. And I'm shading the panel right now, so let me move away. Get it some sunlight. See how fast it goes. 48, 49, 52, 51, 52. Alright, so it's going up. This solar panel is only 5 watts. But it works perfect for this application. You don't want to use a big solar panel to charge 3 18650 battery cells. That's an overkill, and there's a chance it might overcharge the battery. So just gonna let it run for a little bit, and I'll be back and see how it goes. Hopefully it doesn't go over 12.6 volts, which is the maximum that this battery can hold. 3 in series, 12.6 volts. I've been charging my batteries for like 15-20 minutes now. The battery is full, and this is the voltage of the panel. 16, 17 is jumping around, so that means even 15, and it's jumping around between 15 and 17 volts. So right now the battery is full, so I believe the charge controller is switching on and off. That's why it's called full switch modulation. I don't have an oscilloscope right now to measure this. I only have this, but as you can see, the voltage is jumping around, so it's turning on and off very quickly to stop charging the battery. And let's see the voltage of the battery. 12.6869, so which is still acceptable. Once I disconnect the battery, it's going to be going down to 12.6. So right now it's going up and down because you see 12.61, 12.62, it's even 12.60, 12.59. So it's, the battery is going down because the charge controller is turning on and off, limiting the current going to the battery. So it's trickle charge the battery right now. That's what it is. So, and within an acceptable range. So that's pretty good. I have just disconnected the solar panel, and the green light is still on, and the battery is fully charged. And let me show you the voltage of the batteries. It's too bright right here, but you can see it's 12.52 volts. So as soon as I disconnect the solar panel from the charge controller, the battery voltage immediately go down to 12.52 volts from 12.67, 12.7. So while when it's charging, it's the voltage might go up a little bit over 12.6 volts. So it went to 12.7 volts, which is still acceptable. And when I disconnect the solar panel, it goes down to 12.52, which is around 95%. So that's pretty good, I would say. Here's the battery pack that I've been trying to charge. It consists of 3 18650 batteries cells connected in series to produce 12.6 volts. So each individual battery is 4.2 volts at full charge, so 3 of them is 12.6 volts. And this is my homemade flashlight. That's a single 12 volt LED with a heatsink inside. I couldn't fit 3 of these inside here because it's not enough room for 3 18650 batteries, so I have to make an external case and just tape it on. Still works. Does look pretty. That's okay, because neither am I.